Isaac Newton, a 17th century scientist, put forward a variety of laws that explain why objects move or don't move as they do. These three laws have become known as Newton's three laws of motion. Newton's first law of motion, sometimes referred to as the law of inertia, states an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. There are two clauses or parts to this statement. One that predicts the behavior of stationary objects and the other that predicts the behavior of moving objects. The two parts are summarized in the following diagram. The behavior of all objects can be described by saying that objects tend to keep on doing what they are doing unless acted upon by an unbalanced force. If at rest, they will continue in this same state of rest. For example, the soccer ball stays in rest unless some player kicks it. Then it moves and will continue its motion unless it's detained by the net on the goal area. Second law. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. It states that the acceleration is produced when an unbalanced force acts on an object, like mass. The more mass the object has, the more net force has to be used to move it. The acceleration of an object depends directly upon the net force acting upon the object, and inversely upon the mass of the object. Therefore, as the force acting upon an object is increased, the acceleration of the object is increased, and as the mass of an object is increased, the acceleration of the object is decreased. Newton's second law of motion can be formally stated as follows. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the force, and inversely proportional to the mass of an object. This verbal statement can be expressed in equation form as follows. A equals net force over m. The above equation is often rearranged to a more familiar form as shown below. The net force is equated to the product of the mass times the acceleration. Net force equals mass multiplicating A. Here's an example. The shopping cart, when empty, requires less force to gain certain amount of acceleration. When full to acquire the same acceleration, it will require more force, hence, the increased mass from the products it contains. And the third law. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. There are two forces resulting from this interaction, a force on the chair and a force on your body. These two forces are called action and reaction forces and are the subject of Newton's third law of motion. Formally stated, Newton's third law is, for every action, there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. The direction of the force on the first object is opposite to the direction on the force on the second object. Force always comes in pairs. Equal and opposite action, reaction, force pairs. And our last example is, many people are familiar with the fact that rifle recoils when fired. This recoil is the result of an action-reaction force pairs. A gunpowder explosion creates hot gases that expand outward, allowing the rifle to push forward on the bullet, consistent with Newton's third law of motion. The bullet pushes backwards upon the rifle. The force on the rifle equals the force on the bullet, yet acceleration depends on both force and mass. And our last example is, many people are familiar with the fact that rifle recoils when fired. This recoil is the result of an action-reaction force pairs. A gunpowder explosion creates hot gases that expand outward, allowing the rifle to push forward on the bullet, consistent with Newton's third law of motion. The bullet pushes backwards upon the rifle. The force on the rifle equals the force on the bullet, yet acceleration depends on both force and mass.